Hello everyone, good afternoon. My name is Jason Reynoso. I am in the Engineering Management Program.
My name is Ben Husky. I'm a mechanical engineer.
My name is Mary Ryan, and I'm from the electrical department.
And we are going to be talking about the Trolley 790 restoration project. And we would like to also talk about our advisor, that is Dr. Bernard. And I would like to say thank you, Dr. Bernard, for giving us this opportunity. Let's talk about a little bit about the background of Trolley 790. Trolley 790 is a 100-year-old trolley that was basically created by the J.G. Brill Company in 1931. About the problem statement in the project scope, we're going to be basically working in an overall project to restore this Trolley 790, and also for us to be able to restore it, and also for it to be able to travel a 5-mile ride. This year is going to be basically this semester just being about modeling and the stress testing, and we're going to be basically working with the modeling, the material decision, and installation in the next semester. Talking about the project, this is going to be basically a realistic scope of what we're thinking that is going to be basically going to cost. So there are some materials that have been provided as well by our sponsor, that is Involved Studios.
So here we have the outcome that we're looking for. On the left, you can see as the trolley currently sits, we have the framework but no floor. We have some of the exterior panels. And then on the right, we have where we want to go with the trolley. While the specific scope of our project is focusing on either end of the trolley, we want to provide a full 3D render to the sponsor for fundraising efforts in the future.
Now, the general overview, the restoration guidelines, we're going to be basically working with the NSPE codes of ethics, and we're going to basically present also two requisites for us to be actually able to work with this project. Is that the original design has to be safe, and it has to be, we have to keep it as aesthetically as possible. And we also have to consider ethical considerations, that we have to preserve the historical and cultural significance of the trolley. So that means that we cannot add anything that is not related to the old aspect in order for us to restore it to its old glory.
So here we have mechanical restoration requirements. Very first step of this is material inspection. As you can see here, we do have a lot of the frame there. The problem is it's 100 years old roughly for what is there. So in the metal components you have rust, and some of the wooden components you have wood rot. So the goal of material inspection is allowing us to build on the existing frame without having problems arise 5 to 10 years in the future after completion. Once we do material inspection, we want to go into corrosion treatment and frame reinforcement. And again, that will allow us to build on what's currently there. After that, we want to go into body panel restoration. And as you can see in the image, we do still have some of those. We just want to make sure they're intact and look like we want the finished product. Once we get the frame done, we're going to move into flooring and kind of build our way up from there. We're going to do flooring and body panels. And then, as you can see here, in the left on the circle image, that's what previous groups have done. So those beams through there, we trust are structurally sound, but we just want to go through, and in the right two images, you can see some of the beams have been cut off, and some of it's just rotted through. So we just want to make sure that that's all structurally sound before we build on top of it.
Moving to the electrical requirements, we have to make objective documents. First, we need to replace all the existing wires for the trolley by using water standard wires, because they provide better insulation, fire resistance, and of course we're going to follow some national electrical codes. These wires are going to be given for review because
what is the risk management. We're going to basically identify potential risks, parts that are available or any kind of technical failures. We're going to develop also mitigation strategies. We're going to regularly review and update the risk management as the plan, as this project progresses. The quality control is something that we have to take into consideration as well. We want to establish a quality standards of the restoration risks and the tasks, and we're going to implement regular inspections and testing to ensure basically that the work meets all the standards. The scheduling, the time management, we need in charge of that in order for us to deliver a product at the end of the second semester.
So for mechanical specifications, we're working with the JG Vertil 77E1 trolley. It's 43 feet long, 2 feet 2 inches off the ground, 35,560 pounds, and we want to keep it as historically accurate as we can. Obviously, we're going to try to use modern materials, which should cut down the weight, but length, height, we want to keep that all original. Additionally, we have a steel frame running through the trolley. The floor sits on a 3x3 by 5/16 sill. So that's one of the first things that we have to tackle. We want to make sure that the frame is intact so that we can build up from there and get into some of the flooring in future parts of the project.
For the electrical specification, it was found that the electrical city Trolley museum for the Stratum already provides 600 volts, so we are going to work with the supplies in order to design our electrical system. Also, the other specification is regarding the light fixtures. We're going to also interiorize as well control switches to manage the lights, signals, direction indicators. On the right side, you can see some blueprints that describes how the wires are connected for the doors, the lights, the squirrels, the heaters. This blueprint was provided by the museum. It's intended to be used just for reference in order to design our electrical system. Here is a block diagram of
this slide, you can see where we want to take it to with the doors, with the wooden flooring, with updated paint and refurbished exterior panels. On the left, you can see a close-up of some of the panels with the windows. And then here we have an interior view, so this is what it's going to look like walking into the trolley. We have the ramp there, which was a client request, as well as on the right, you can see a little bit better view of that ramp, and that's just to get from the entrance into the seating area and slight entrances. Here we have some of the components. On the top, we have sub-assemblies, the frame, the windows, and the headlight housing. On the bottom, we have a couple of the components. We have this drop beam here. This is going to be one of the first things we replace that's right inside the door and helps support the floor where people walk on, or where they enter. And then here we have a couple of different panels. We have exterior and interior panels. The one with the hole cut out is the one that the headlight housing goes through.
Here we have some electrical schematic for the two controllers. It's have the same basic principle of the block diagram that I showed previously. We can see they share the same circuit, but they are connected parallel in case one stops working, because still working. They are connected to the motors. They might be connected to zero or parallel. I still don't know what kind of motor are we going to use. Here are the auxiliary components. We have the lights and heater and buzzer. You can see that here have a relay on it because it draws high current, so we have to add a relay. Which is good for high current.
For our conclusion, basically, for our work this semester, we would like to present basically the schedule that we have to follow for the spring semester 2025. As you can see, this is basically the hands-on, the next stage of our project. And before we jump into the questions, I would like to say thank you, students, for bringing this project at Bose University. We appreciate you for doing that. Questions?
As far as your 600 volt DC, so you're not entirely doing away with that power, 600 volt power. You're still using it for the trucks, and your inverter is just powering up all of these other incidentals on the trolley. My understanding.
Yeah, they use their circuit to the controller. Just the controller department does 600 volt, 60 years, 600 volt.
The other question would be your wire current ratings. Could you go back to that slide? It seems to be underrated, like your number 10.
Oh,
You know,
yeah.
Is that a little bit underrated?
I chose those ranges because we still have perform some testing where you choose the correct model. Just that way for power distribution.
Other questions?
Could you go back to your slide number 3? Right here. No, next one. Next one. Number 3. Yeah. Go back. This is 7. 3. Go back. It's a third slide. You're going the wrong way. There. Right here. Doctor, these pictures are full of confidence. I feel much better. You guys say name there. Because you guys are too honest. So, seriously, you think I'm joking? I'm not joking. Because we all know the history of this project. So you guys said like you didn't get anything from last year. That's something I feel very kind of disappointing because that's, as an engineer, think about this. You did a project that somebody else come later and couldn't even furnish any benefits. That's a waste of resource and time. You see what I mean? So what did you inherit and what knowledge did you learn from last year?
Basically, we were over all the information we had, and it was basically starting from scratch.
So why do you have to start from scratch? And you didn't think anything from last year was valuable? Is that really that extreme?
No, we have a couple of things that they did. We do trust their calculations for stress at the beams that they replaced. We do have some of the drawings that they did, but just in like the final report, we don't have anything that we can download or any like files that were saved. So yeah, we started from scratch with the drawings, but did use the basis of their reports to form our ideas.
Okay. So I want to cut the chase. I almost want you guys to name your project a Terminator, because otherwise we have another group next year work on this again. So again, you're looking to make this perfect. My question to you is very simple. What are the two goals you are trying to accomplish? At the end, you can call your project a success. I need to know those two things. So at the end, you say, I think that, because you won't get to do all the electronics, all the electrical, all the mechanics, it's impossible. So tell me two things I will achieve those two things, that I can call this project a success.
So the biggest thing for me for mechanical was
As specific as possible, because that's something I would use to gauge it at the end of the next semester to see if this is a successful project or not.
The drawing package was big for me, not only because we could use it for our designs, but also for future fundraising efforts. So that was one thing that we know that we need to complete. Additionally, we do want to finish the beams so that they can start laying flooring when they get that material.
So that comes to my next question. Mechanically, what do you think is the most urgent issue with the current system? Like, if I fix that, I think it's in good shape. What's the mechanically the most urgent need for the system?
Absolutely, material inspection and then reinforcement.
No, I'm talking about specifically which structure, which part you think is most important at the same time, most desperate need, like the restoration.
Framing. So the floor, right when you walk in, go one more picture. Two. We don't have any of the floor right there. You can kind of see in the bottom of the left image, we have the cut ends of the beam, but if we could replace that, I would say that would be enable the flooring to go in, and that would be a successful.
So you think that's the most urgent need, okay?
I would say.
All right, well, I'll put you on the spot, okay? At the end of the next semester, if you don't get that done, I'm asking for you to feel like that, right? Just kidding. You see my point, right? You see my point, because let's be specific, cut the chase. That's urgently what you need, let's get that done. Focus on that, let's get that done, okay?
I did talk to Maylee a little bit about these motors that have to be controlled. And my understanding is the original trolley motors were no longer with the trolley. Is that right?
That is correct.
Okay, and so the motors that you're intending to use are different motors than the ones that were the type of motor that the trolley originally came, or are they the same as the trolley originally had?
I think Bailey can address that question, please.
We still don't know. We have to ask to that museum because they are the one that are possible to use that.
I'm sorry, can you speak up?
I'm sorry. We still don't know because we have to ask the museum about that specification because they are the one that requires to use that kind of.
Right. So you've been told to use this particular motor,
Yeah.
but is that motor compatible with this
We don't.
K35 controller? And as far as I know, you don't know yet. Is that
Yeah,
right?
because it was a list of the components, and in that list there was the different controllers with the E241 models.
But as I understand it, you didn't know at the time I talked to you that these were DC motors. They could have been AC motors. That was unclear, and maybe they're series wound motors that'll go with either AC or DC. That's what I assume was there in the original trolley. But, I mean, it ran off 600 volts DC, and those K35 controllers seem to be built for that kind of motor. So I think there's some questions about the motors that have to be resolved before you know what you're doing with that.
We're going to take that into consideration, take information in that, and that is going to help us a lot as well. And for the next semester, when we have the chance, we would like to discuss that with you a little bit more. We're going to talk about this information in order for us to basically give a good project at the end of the second semester.
If you can get a hold of one of those motors and see what it actually is, you know, for example, if it's got 3 wires coming out of it, whether it's got 4 wires coming out of it, or whether it has 2 wires coming out of it, you know, what exactly do you have there? You need to find that out, and then you can make a decision on how you're going to control it. I hope you can control it with these K35s. They're in the are they still in the trolley? These K35 controllers?
They're not in the trolley, but they do exist and they're set up to, I think they've already been donated. They're just at a section.
So that you have workable K35 controllers,
As far as
which are designed for series wound motors, it appears. So, you know, just make sure that's what you've got.
Okay, thank you.
Thank you.
So maybe Dr. Gilmer is truly an expert regarding all the electronics installation. He is truly an expert. I'm not even joking. I'm not joking. Running on the train. Yes, if you can really get this out, you're going to really make some good progress. So truly take one step at a time, because don't try to do too many things. Like just one thing, you can't do obvious stuff. One thing, electronically, get done. Pick those 2 things, we can call this success. So just really, he can help you to achieve that, okay? Right now,